guys, welcome back to another episode here. This episode is pretty much just going back over the basics that you kind of learned in probably it was either trigonometry, calculus 1, calculus 2, but regardless, this should be more of a review, and if it's not, just continue like it is. And then if you guys get confused, make sure to leave a comment down below, and we'll try to explain it a little bit better here on the channel. Or you can look up some follow-up questions on some of our other playlists. Maybe that'll help you out. So for our normal viewers, you know the drill. Just try to go along with the video as best you can. Make sure to pause it for 30 seconds and then continue on with it. So for this one, we're just going to jump right in. The value of this equation is most nearly what? So the part right here that you kind of don't see is this equation here. It is the integral of parentheses 1 plus the cosine of x n parentheses squared times sine x dx to the 0 to pi over 2 limits. So in order to solve this equation, it goes back to a very similar problem that we had. It's probably coming out this week, so I highly recommend it. It is all about substitution. So what we need to do is the following. We need to come up with a letter, so in our case, z, and set a portion of this equation equal to it. So for us, it'll be 1 plus the cosine of x. Okay. And just like substitution sounds like, what we do is we plug it in and it allows us to implement it. So what we can do is we can realize that the now integral is going to look something like this, z squared, but then we also have the sine of x to the dx. So how do we solve this? Because we just set this part equal to here. And so the next thing we need to do is we need to realize that z is also equal to dz. And so what we can do from there is we can realize that the derivative of this particular 1 plus cosine of x is going to be 0 minus the sine of x. So that right there allows us to solve it accordingly. And so what we have here is we just plug in a dx here and it works out beautifully because what do we have right here? The exact same problem. So keeping that in mind, we've now taken the derivative of 1 plus cosine. We've substituted in for these following, as you can see, the arrows, this area to that area to that area. Then what we've done is we've taken the derivative of the z, which is just dz. And if y'all are curious where this dx kind of popped up from, this dz for most math guys is actually dz over dx. And so this dx goes over here. So with that in mind, we can now substitute it in, but for simplicity's sake, what I'm going to do is I'm going to kind of wipe this away and start over. Just bear with me while I clear the board here. Boom, boom, and more boom. Okay, so keeping in mind what we just saw, we saw that z is equal to 1 plus the cosine of x. What we did then was the dz is now going to be the sine of x dx. And so it just works out very beautifully to come up with an equation very similar to